Hi, everyone. This is Aaron Larson, executive editor of Power Magazine, and you are listening to the Power Podcast. On today's episode, I'm joined by Dave Fernandez, Jason Wheeler, and Spencer Hamilton. All three are with MDNA, and I'll let you each tell a little bit about yourselves and what you do with the company. So, Dave, why don't we start with you? Thanks for joining me.
Thanks for having us, Aaron. So I've been in the power industry since I graduated from Mass Maritime back in 1996, and I started off in the industry with GE, and just so happens that my focus with GE was on the gas turbines and in the time frame that actually lines right up with this topic. I was a GE field engineer servicing the Frame 7 and Frame 9 fleets through the world as a startup and DLN specialist from 1996 through 2001. So I saw a big part of the bubble that we're going to be talking about here in a little bit. And for about a decade, I ran power plants, and then I came back to MDNA and ran large outage service projects, ran manufacturing for a good chunk of time, and then came over and took over the gas turbine rotors program about 2.5 years ago. So I've kind of come full circle.
Sounds like a great background for what we're going to be talking about, and we'll get into that in a moment. But Jason, why don't you tell a little bit about yourself and what you do with MDNA?
My background's a little different than most in power generation. It seems like I am a military person by trade, I guess. And I left the military back in 2008 and fell into conversations with MDNA in 2013, and I've been with them ever since. I started off in the valve shop in St. Louis with MDNA, and I ran that shop for about 8 years. And now for the past 5+ years, I've been running the gas turbine rotor repair shop in St. Louis. It's a very large shop with lots of resources, and it's a fun place to work and a fun group of people to be with, and obviously the work is very interesting and fun as well.
All right, thank you. And Spencer, last but not least, why don't you tell us what you do as the Gas Turbine Services Sales Director?
Yeah, so I'm responsible for the overall turnkey offerings that MDNA brings to the market. For the gas turbines, bringing along some of our legacy products, a steam turbine and generator to, yeah, again, give that turnkey solution to our customers. My background's a field engineer with a OEM on gas turbines. I've worked for a couple of different service providers over the years. Been in the industry for going on 15 years now.
Great to have you. And obviously, Dave kind of mentioned the fact that we're going to be talking about the 7FA and some of the things that have happened over the years. Back in the early 2000s, the gas turbine market was kind of in a boom. Can you talk a little bit more about that and how that developed?
Yeah, so back in the started in the late 90s, deregulation came into play, and there was a rush to the quick build power plants, which were simple cycle, combined cycle gas turbines, and the GE7FA and 7EA. Both of those were very popular units at that time. A lot of people will remember Enron being a big part of that and how they helped drive that and then helped end it to some extent as well. But that's essentially what the bubble was. It was a rush to market by a lot of independent power producers and some utilities with quick to market power generation assets, which were gas turbine based.
And what did that mean for GE? I mean, they sold and installed a lot of turbines at the time.
Yeah, it was quite a challenge for them and other OEMs at the time to be able to scale up from a production standpoint to support the demand. GE, and particularly, if I recall correctly, through international partnerships and expansions at their own facility, they more than doubled their annual capacity for producing gas turbines during that period of the bubble.
And if we fast forward to today, a lot of these turbines are now 25 to 30 years old. What does that mean for their remaining life, and why is it important for companies that are operating these turbines to start looking at that and planning for the future?
Well, the OEMs have set, certain components in the rotor themselves have life limiting factors, implemented on them. You can run beyond those factors if you choose to, but there's a huge risk to do so, and that's why those limitations have been placed. Not planning for those hours and the completion of those hours will leave customers in a hole, so to speak, if they don't plan early.
And what are some of the biggest risks that they face if they're not planning and thinking about the extending the life of these rotors?
The biggest thing in my mind is going to be component availability. So even now, we're at the very front of this bubble, right? And there's issues with trying to find components and vendors that can manufacture these components and the lead time that it takes to manufacture these components. It's not like a it's not like a steam turbine where you lose a major component and there's 20 different vendors that you can talk to and come up with parts, and you might have blades or whatever in 12 or 14 weeks. That's not going to happen if you need a 7FA.03 T1 turbine wheel. If no one has one, you're going to be waiting years. And then what's your backup plan there? So if you don't plan for it, you're going to be the one stuck in a hole, and you don't want to be that company.
Mm-hmm.
Maybe one thing to add there is maybe also not having the opportunity to understand exactly what the given customer needs. I don't think every customer needs a full-blown new rotor. Maybe they can get away with something else, but if you're reacting to coming, up on the time clock, the only option would be a new rotor. So the more advance notice, the more time they have to do their homework and see what options are out there.
Yeah, it's always better to plan for something than to have it forced down your throat at the end when you weren't expecting something.
Right. Things are going to change regardless, but if you don't start with a plan, you're never going to get anywhere.
So what role do these aging assets currently play in our overall energy mix, and how critical are they to the grid reliability?
Yeah, so we're seeing the 7FAs as well as the EAs predominantly, base loaded units, especially with this boom in AI, and any assets that are not being used. We're even seeing them move to areas where they can be utilized. So I would say they're critical, especially with the demand of new units. Only so many can be made, and that lead time being long. So these assets are being ran longer and more than I think what might have initially been expected.
What are some of the most common damage mechanisms that you see in these aging E and F class rotors?
There's lots of on the compressor side, right? The aft end of the compressor, you get cracking in the dovetails. So there's some enhancements that have been made by the OEMs and us as well with the geometry of those dovetails. So there's some known upgrades for known issues, but then there's also unknown issues if you've had events in the past, right? Everything adds up to whether the rotor components will have life in them or not. If you've had a lot more starts versus base load runtime, if you don't have clean air going into your compressor and you have oxidation and corrosion issues, and then the forced outage and wrecks, but that's not typically tied to end of life unless you're just running well beyond what you're supposed to and something bad happens. You want to catch it before something bad happens, or it's a much bigger issue.
Mhm.
And especially in the super alloys and the ink alloy based wheels, it's a very robust super alloy that holds up well in high temperature conditions. The downside of it is when there's a crack initiation, which in this case is a fallout from low cycle fatigue. Creep doesn't really come in with the temperatures it seems, but low cycle fatigue is the concern in these. And there's micro cracking that takes place after so many cycles, and that's what the limitations are based on. The OEM limitations are based on when they forecast those micro cracks to start taking place. When those micro cracks themselves aren't a problem, but when they start connecting, that's when you can get into some problems and quickly. on these superalloys. So they're a robust material. They're great for the environment which that they operate in. But when they crack, they oxidize, and crack propagation it accelerates in these superalloys more so than on the compressor side, which is chromoly B, and doesn't see the same crack propagation rate that the superalloy does.
Interesting. So are all of the 7FA rotors the same, or are there design or manufacturing differences within the fleet?
So there are some differences, right? For me, with the tear down or unstack and restack, there's some minor geometric differences from some rotors one to the next. The larger picture, the larger question I believe you're asking, there are some differences in the way that some rotors have been designed. There's some different things that some companies are doing that others are not, and there's some enhancements out there that are available, like from the aft shafts, right? So there are some differences within the turbine sections that you'll come across. There's some geometry differences on the rotor as a whole, but generally they're thought to be interchangeable, right? So plug and play, but there are some differences.
And then there's some evolutionary differences that Jason alluded to one earlier, but there's just like with any product line, there's lessons learned, and the lessons learned lead to enhancements and upgrades. So there's quite a few enhancements and upgrades that have taken place on the 7FA over time. The one that Jason had alluded to is the back end of the compressor had flat slot bottoms. Most people that run these assets know that the flat slot bottoms, when they open the unit up and they inspect them, they're going to have cracking on the trailing edges. So one of the enhancements that came from the OEM that we also deploy is the round slot bottoms. There's other enhancements on the turbine side of the coupling that also have enhancements to mitigate cracking that would take place in the cooling slots on the balance wheel. So there's differences there. There's a limited number of options in terms of who can manufacture and provide these the superalloy components that go into a rotor lift extension. And the differences you'll see there is the OEM and as well as MD&A deploy the same superalloy. We deploy the same superalloy because the more expensive options that are used in like the H machine aren't necessary because the material in the H machine, for instance, is an ANCO 718. ANCO 718 is necessary when you get into creep conditions. You don't get into creep conditions on the 7FA. So it's a more expensive material that guards against creep, but it's not necessary on the 7FA. It just increases your costs. The value it provides isn't required, so you're not getting what you pay for. So there are differences when you go from one solution to another, but at this point, for the most part, the geometries for the different components you'll see and product offerings have all taken into account upgrades and enhancements to guard against issues that have been seen from a crack initiation risk mitigation standpoint.
And we talked a little bit about the fact that demand in the electric industry is increasing rapidly, and that's impacting manufacturing and other things in the industry. There's outage constraints to think about. There's other items. Why should customers be thinking about their rotors now or for the next 3 to 5 years? What's the urgency behind this?
Like we were kind of talking about earlier, this demand on the energy is causing capacity constraints, right? I think the big thing, why to think about it now, is for a customer can have options, not be forced down a route. I know I would want options when I'm looking for a new car. I think customers should have that option as well.
Mhm. What about supply chains and the delays or the lead times that are required for some of these components? Do those factor in as well?
Very much so. There's not a lot of different vendors in the world that can actually produce these components, right? They're very specialized materials that are specialized process to produce them, whether it's the forging themselves or the machining aspects. So if you're not thinking 2 to 3 years down the road on your rotor, then you're already behind because that's how long it's going to take to manufacture those wheels, right? So MD&A is poised in a good spot to have those wheels on hand in St. Louis. But there's not an unlimited amount in St. Louis, and there's not an unlimited amount in the world. So unless you want to get left behind, you're going to have to plan. You're going to have to plan early. It's not like on the steam side where everyone says plan 6 months to a year out. You're gonna need to be 2 to 5 years out planning if you want to be set up for success.
The other thing that compounds that is the other industries. The other industries are booming right now. The forging houses all support the multiple industries. So you got the aero, you got the power generation boom that's happening right now. That's consuming a lot of the forging houses lead times, and then you have military. So all three of those have large orders in place right now for new. So now we're talking about competing with those new unit sales across various industries in attempt I guess get in line and with what is perceived from some angles as higher priorities with replacement wheels for aging assets. So it further complicates the scenario that the industry is facing, that the customer base is facing when they're trying to extend the rotor life of their existing assets, which is becoming, again, more important now because of the power surge we're seeing and the forecast we're seeing that is based on the server demands and the current and future. So I think there's a lot. We went through a bubble before. I lived through the bubble before. There seems to be a lot more concrete reasons and a much stronger foundation for this current bubble than the previous one that took place 2.5 decades ago. There's a lot of things that are all stacking up at the same time that put some more of an emphasis on getting out in front of extending the life of your current assets now, probably more than ever in the time that I've been exposed to the power industry.
Have you seen that reflected in prices as well? Have the costs for these components gone up significantly due to the supply constraints?
Absolutely. And we should expect them to continue to go up. Additional complications come into play currently too is with tariffs, but those are unpredictable right now. They come and go, but supply and demand has forever been a part of every industry, right? And the demand is high and the supply is squeezed right now. So we should all expect the price tag to increase.
Going a little bit more into the rotors and the life extensions, at what point does a rotor become a run to failure risk versus a viable life extension candidate? And are there indicators that owners should be watching for?
The first thing is once you go through one life extension, right, you're typically not going to go through another. So once you go through the first one, you're going to have to start looking at either purchasing a new rotor way down the road or run into failure. I personally would not say any rotor would be run to failure. I would say take it apart, look at it, investigate and inspect it, and figure out what the issues are. And then it doesn't have to be a run to failure. There's going to be some instances where maybe the whole rotor might be a fallout or scrap deal, but those are going to be way few and far between. I mean, we can repair a lot of stuff, and NDNA has the capability to produce lots of parts, and we have lots of very expensive capital parts on hand. So my personal opinion is to never say that a rotor is run to failure until you absolutely know it. And I don't know that I've ever necessarily come across one that I would say, yep, there's nothing you can do, run it till it dies.
I think it's as simple as adhering to the limitations put in place. Because once you get to a rotor life extension trigger or a rotor end of life trigger, I should say, based on the OEM's guidance, and then based on the guidance that you're given by the service entity that extends the life of your rotor, if you go through the very detailed rotor life analysis that comes along with that program, you're going to know whether or not your assets are at risk or not. The ultrasonic testing, the eddy current testing, the dye penetrant testing, the material analysis, you're gonna know whether or not you've had property changes that put you at risk with the rotor life analysis programs that are in place. Originally, the 70A was never meant to go through more than one rotor life extension, but now you have 70As out there that have been life has been extended twice. We're not there yet on the 7FA, so before anybody can say the 7FA can be extended a second time, the fleet leader needs to get there. Some destructive testing probably needs to take place on multiple components, and then a determination can be made. The most likely scenario is they will also be able to be extended, but the number of components that'll have to be replaced will be expanded beyond what the current standards are. So to Jason's point, I don't think you'll ever have to, as long as you adhere to the limitations put in place, and you have your predictive maintenance rigor and your preventive maintenance rigor, and you're going through the in-depth rotor life analysis, you really shouldn't be at risk of running one of these assets to failure. You should never risk that.
Mm-hmm.
From the personnel safety standpoint, you should never flirt with that, right? Just starting and ending right there. You should never even consider that an option.
From an operational standpoint, how do unplanned rotor issues typically show up? Are there performance degradation indications or vibration? Do you find it in inspections or forced outages? What do you typically see that happens first in these things?
Changes every time. A lot of them show up simultaneously, right? But one of the failure mechanisms has been stage bolting, T1 stage bolting. You have a T1 stage bolting issue where you have a failed bolting assembly. It's going to show up in your vibration profile, right? But if you have micro cracking taking place in your cooling hole geometry and your turbine wheel or on your lock wire tab, you're only going to find that during inspection and through a dye penetrant test. The microstructure cracking that initiates on the turbine wheel, you're not even going to find that with a borescope. So there's cracking you're going to only find through a rotor life analysis. And then there's other cracking that you're going to find that Jason alluded to earlier on a flat slot bottom wheel. You may be able to see that with a borescope. But there's different elements that you're going to have to go through the whole rigor of preventive maintenance in order to ensure that you're guarded against it all. So vibration will pick it up, and sometimes performance decays slowly over time. The only time your performance is going to probably be an indicator is when something else goes with it. Like if you have foreign object damage in your compressor, it's gonna show up probably in your vibration profile and your performance. You're going to find some things with borescope inspections and some things you're only going to find through the detailed analysis that's done during a rotor life analysis.
How have inspection techniques evolved since these rotors were first installed? Have you seen big changes in technology that allow you to see and find problems more easily today?
I believe on the NDE side, there's certainly been some growth there. On that specialized NDE, we use a vendor that we partnered with. So luckily for us in those aspects, we haven't had to make those R&D investments or growth within MD&A. But there's an industry-leading vendor that we have partnered with that does our end-of-life NDE section of that inspection that has some very high-tech inspection methodologies. Volumetric phased array, where you can basically fly through the part and look for imperfections. That was a new one for me. There's just lots of neat inspections that they have the capability to do that you don't see anywhere else, like in, let's say, the steam world down at the other end of the shop.
And I think a lot of the inspection methods have been in place for a while, like the phased array, but they've just been enhanced, particularly on the software side from the analysis side.
And the tooling,
the tooling itself, the geometry of the tooling. So it's definitely enabled more thorough inspections over time. I don't know if there's new technology that's been involved, but the technology that's been in place has been evolved to provide more thorough inspections of honestly all power plant equipment, not just the rotors.
Lots of our internal methodology there in the shop is centered around, safety enhancements. From the first time we took a rotor apart till now, we've overturned a lot of our tooling and made it better, more ergonomic, and just more safe for the people who use.
Mhm.
I can say this: the where there's been significant enhancements is on the R&D side. Much more precise methods have come into the marketplace over the last couple decades to enable more precise, accurate reverse engineering methods. One example is blue light scanning.
Mhm.
That's been evolved and improved on, and it's a very tightly tolerance method for reverse engineering.
And what's one thing that you see owners misunderstanding when it comes to rotor life extension?
Some of our customers don't understand the aspects of what it takes to do the inspection, and the timing and the cost, and the known plan. Our known plan may be different than the OEM's known plan, and the difference is there, right? When somebody is dealing with one vendor versus another, there's just going to be some differences.
I think one thing they don't understand is what I was alluding to earlier, and that is if you make certain decisions in terms of your rotor life extensions, there's upgrades you can perform along the way that'll get you performance improvements. And more capacity is a popular thing, right? A higher performing unit with more outputs, important. Customers should go in, should get educated and understand what sacrifices they're making. And it was what I was alluding to earlier. If you make certain choices in terms of what you do during a rotor life extension, you may pigeonhole yourself to a single source provider, which inevitably is going to create lead time and schedule impact problems. When you have one solution available to you, more often than not, you're going to find yourself between a rock and a hard place. No one wants one solution. It's just not a good place to be. So understanding what puts you in that scenario is probably the most common misunderstanding or missed contemplation that I come across in the customer space.
If there was one piece of advice that you could give to an operator who's managing a 20-year-old gas turbine today, what would that be?
Pick up the phone and start a conversation. Nobody knows everything. You don't know what you don't know. Operators know how to run their units. They don't know necessarily the fleet-wide problems or have the experience of a shop seeing 20 rotors go through the shop at once. So pick up the phone and have a conversation. I would say that to everybody, right? That's the start to anything. So learn what you don't know, get educated on what's there and what's not there so that you can plan for the future. And then go from there, right? Make those decisions and act on them.
Yeah, just to tie into what Jason said, I was going to say get educated. Take the opportunity to visit multiple vendors. Go look at their shops. Ask the tough questions. Yeah, get educated.
My suggestion ties right into that, actually. Understand what your decisions do from an optionality standpoint. There's certain decisions that customers can make that will tie them to one solution, which is the OEM. And the OEM is very focused right now on new unit sales, understandably as it should be. But if you make certain decisions and you're not aware of the intellectual property constraints that ties you to, you're going to have a single option solution. So what Spencer said, I'd say get educated, but to get educated on what is going to limit your options. Because if you limit your options to one single source right now, you probably are going to be in a tough spot.
All right. Well, thank you, gentlemen. Again, for listeners, I've been speaking with Dave Fernandez, MD&A's Gas Turbine Program Manager, Jason Wheeler, MD&A's Gas Turbine Rotor Repairs General Manager, and Spencer Hamilton, MD&A's Gas Turbine Services Sales Director. So thank you all for joining me. Is there any last words or anything that we haven't talked about that you think would be important to mention before we wrap this up?
No, just thank you for the opportunity to speak with you, Aaron.
Thanks, Aaron.
Thank you, Aaron.